All right, looking at example 3, it says a museum vault has an outer steel wall with a uniform width of X. The area of the vault ceiling in the outer steel wall is 1,664 feet squared. What is the width of the outer steel wall? So we are looking for this missing X value. Now, what we need to first find is we actually know the area of this entire steel wall. But the issue is that we only know that this small section here is 20 and that this small section here is 40. But we need to know the entire length and the entire width of that ceiling. So we're going to have to somehow incorporate X right here. Now, X is this width all the way around that kind of completes our lengths for us. So each of those blue lines that I drew in help us to form the full length. So I'm actually going to erase a little bit from this last question to make some room. Starting with this side here. So this part here is 20, and we have to incorporate the width on both sides. So we have to add X on to the right and add X on to the left. Now, when I simplify here, add up those like terms, we end up with 2x plus 20. Now, same thing over here, just this small part here is 40, but we have to incorporate X on the left and X on the right. That is our width all the way around. When I simplify this, we end up with 2x plus 40. So right away, we have our factored form. We almost look like we're ready to go, but here's the problem. Before we solve, we have our factored form set equal to our area, and we need that to be set equal to 0. Right now, we don't have that. So what do we have to do? We have to minus it. Let's go ahead and subtract it across. Zoom in here. All right, so once we subtract that across, we're still running into a bit of an issue here. We're not fully in factored form, so we're gonna have to do some simplifying. Because factored form, I can't just have a random number on the outside of my parentheses. We have to have only 2 sets of parentheses set equal to 0. So what we're gonna have to do now is we're gonna simplify this. We're gonna use our foiling from topic 7. We're gonna simplify that, try to combine some like terms together to make this into our standard form, and then we will work backwards and factor. All right, let's go ahead and FOIL. So when I multiply 2x and 2x, we get 4x squared. 2x and 40, we get 80x. 20 times 2x, 40x. And lastly, 20 times 40, we get 800. All right, and then I'm going to go ahead and bring down everything else. That first step right there was we factored because we FOILed, so that we can do some simplifying. All right, let's look for some like terms. I see some x's we can combine. I see some constants we can add together. All right, when I put those like terms together, here is what we're looking at now. 4x squared plus 120x minus, let's see, 800. We have to add that to negative 1,664, and I am getting negative 864. All of that equals 0. All right, we're back to standard form. Now that we're here, we can work backwards and try to get back to factored form. We had to combine some like terms, though. And now we are ready to factor. The issue is my a value is not 1. So the first thing we want to check for is, can we factor out a GCF? Is there a GCF that I can factor out from, we're looking at numbers 4, 120, and negative 864. We're looking for our coefficients. And turns out they're all divisible by 4. So we're going to take 4 out. That means we're going to divide 4 by each of those 3 terms. And if you need your calculator, go ahead and take it out now. When we divide by 4 on the first term, we're just left with x squared. When we divide 120 by 4, we get 30. And then, of course, the x is going to hang out on the end still. And then we have to do negative 864 divided by 4, and we get negative 216. All right, and then all of that still equals 0. Now that we factored out a GCF, our A value is 1, and we are ready to now just focus on the inner part of our quadratic and solve that. We have to factor this one more time so we can now use our zero product property. So here's what we're looking for: two numbers that multiply to C and add to B. Now, I don't know this off the top of my head. I don't really know a lot of factors of 216, so I'm going to take out my calculator and start dividing 216 by some numbers. And I'm just going to kind of write those above. So I found that 4 and 54 multiply to 216, but I don't think we're going to get those to add to 30 in any way. So let's keep trying. 216 divided by 8. Okay, 8 and 27 go into 216. And I don't think there's going to be an easy way to get those to add to 30. So let's keep going. 216 divided by 2. Okay, 2 and 108, that's not going to work. Let's try 6. Okay, 6 and 36, that might be our winner right there. So I found that 6 and 36 multiply to 216, but we need them to multiply to negative 216 and add to a positive 30. So we're going to have to make one of those negative. And in order to get to a positive 30, that 6 is going to have to be our negative number. So let's try this. If I multiply negative 6, positive 36, we do get negative 216, and those add to 30. There is our factors. This was a lot of work just to get to our factored form, but here we go. We're ready to do our zero product property. We're going to take our two factors, set them both equal to 0. Since this guy is just a constant, the 4, we can kind of ignore it. At this point, it kind of doesn't matter. Now, if there was a variable right here, that might be a different question. But right now, if it's just a constant, we can kind of ignore that 4. And we're just going to focus on our factors and solve those. When we do, we should get x equals 6 and x equals negative 36. And since we're talking about width, an actual real-life problem, you think we can have a negative width? Nope, we cannot. So we're just going to disregard that answer for now. Negative 36 is technically an x-intercept if we graph this on Desmos. But for now, since we're dealing with a real-life situation, we're just going to focus on our positive answers. We can only have positive distances. All right, guys, we are going to do a question like this in class, so you're welcome to skip this one for now.